In this demonstration, I want to introduce you to the NX 2D nesting application. For this release, nesting is dependent on the sheet metal application, as each part to be nested is required to have a flat pattern feature that's used for the nesting program. We're in the sheet metal application now, and if we look at the flat pattern display, we need to make sure that the layer assignments align with the nesting parameters that are added within the nesting dialog. So for example, anything that I want to be a cut right the way through the material, my exterior and interior cutouts for example, I've assigned to layer 1 along with hole features and lightning holes. Anything that I just want to mark on the surface, I've assigned to layer 2, such as center marks and any text. So we launched the nesting application directly from the home tab of the sheet metal application. And here I'm just going to make the dialog a little bit larger depending on screen resolution. This is just so that we can see everything that's going on here. So we'll walk our way through the 4 tabs of the dialog and all of the settings as we go through. So we have nest direction, edge to part distance and part to part distance. Are simple setups of where do we want the nest to start, how much space do we leave around the outside of the parts, and how much space do we want between parts. And then we come to the cut and attach layers I mentioned in the flat pattern display dialog. Cut layer I've got set to layer 1, and attach layer I'm going to define as layers 2 and 3. We then come down to the nest input file where I can save my settings once I've finished, or I can load a previously saved job, which saves a lot of time for repeat jobs. I then define my standard stock library, and here I'm just using the library that comes with NX out of the box, which has a reasonable array of materials, and I specify my output file name, and here I'm just going to call this test01. This is the output path that the DXF outputs from nesting, and also the part files and any log files are actually saved. We then move across to the stock tab, which I can define what stock I have available, but in this demonstration I'm going to go to the parts tab first and see what stock I actually need for my assembly. I can add DXF files, but in this case I'm going to add NXPRT files, and I'm going to go and select my parts. And I'm going to select an entire assembly. I don't have to go through and select individual parts, although I can do multi-select. But I'm going to select this assembly, and I've got my include sub-assembly checked, so when I select this and apply, it actually loads the entire assembly for me. I can then go ahead and select further parts from different locations, but for this demonstration I'm just going to nest this one assembly. Now I can see what material I need and what thicknesses I need. So most of my parts here are 1.2 thick, and I've got a 3mm thick part here, and I'll come back to the other settings in just a minute. So let's go and load up some 1.2 thick stock. So we go back to the stock tab, and I'm going to add either custom stock where I can just define a size and a thickness, or I can go to standard stock where here I'm going to choose metal, which is aluminium, and my thickness is 1.2, and then I'm going to use a 2 by 1 meter, and I'm going to do the same again, 1.2, and I'm going to add a 3 by 1.5 meter, as these are the stocks that I have available. Now when actually nesting, you can do 2 paths. You can either add all the parts and fill up the available stock. So in that case you would put the quantity of stock that you have and then do a large amount of quantity of parts. Or you can say specify the number of parts I have and tell me how many bits of stock that I actually need to use. I'm going to use that second method here, so I'm just going to up those quantities to 3 each to make sure I have enough, and I'll go back to the parts tab. So let's work our way through here. When I loaded this assembly, any parts that have a quantity are actually added here, and the quantity is added. Now I don't want to nest just one of these. I'm going to come down to the batch quantity. I'm going to nest 30 sets. So that means I have 30 times 4. I'm going to get 120 of these clips in my nest and 30 of everything else as mentioned. So let's now move across the columns. Rotation. If grain is important, specify the flat pattern direction aligned with the grain direction and set your rotation to 180 so the parts will always be grain direction aligned. I can specify that things can be turned in 90-degree steps. I can say that the parts should never be turned or just have a free arrangement and let the nesting algorithm decide the orientation of the parts. I can also add a tolerance to that, so if I have a 0, I can actually put a 1, 2, 5 degree tolerance on that if that's permissible. But that's not relevant if I've got a free rotation anyway. I can allow or disallow mirror. If you have a different material or coating or finish on one side of your stock to the other, then obviously you would uncheck this, otherwise some parts may come in upside down or mirrored. I can prioritize some parts over the others, so if I'm creating parts to use up stock and I want certain parts before others, I can define a priority to say if this is highest, then it will make sure all of that quantity is nested first before it moves on to the others. And my status indicator tells me what's valid, what will actually be nested. And even if it is valid, I can actually exclude it and not nest it. So once we've got all of that defined, I can even take away parts that are not valid. It's just a visual thing here. My assembly does not have a flat pattern, so will not be nested. And we move across to our processing tab. So here we have a nesting time limit, which is set to 60 seconds. I'm going to set that to 10 seconds and then explain what that means just by pressing the start button. So the nesting job starts, and what it's doing now is that it's pre-processing or loading in the parts that I've selected in the parts tab, finding that they've got flat patterns, and then defining the layer assignments as specified in the work part. It's loading in the stock availability and providing that to the nesting server. And then this nesting time limit really refers to how much time the nesting server spends on trying to process the information and generate an efficient nested output. So once that process is complete and nest results appear in the dialog below, and we'll just wait a minute or two for that to finish. So the nest results have completed, and we can see that I've got 8 passes that it's done within the 10 seconds. So just under one a second. And we can see that its first pass had a utilization of just under 70%. And it used 3 sheets, but it did manage to nest all 210 parts in my assembly. Right the way through to the final pass here, which is just a little over 82%, and it only uses 2 sheets. And you can see literally from the third pass right the way through, I didn't really get any improvement, so maybe even less time is sufficient. Once I've got to my final point here, we can actually see the stock usage, and that lists the cut length, the utilization, how many parts are on the sheet, how many sheets are actually used, and the length and width. So the length and the width, or the length and the width of each nesting job, and they can also be shown here. Maybe there's a remnant on one of these stocks and it will tell you how much is left there. So if I'm happy with that, I can go back to my nest settings and I want to repeat this, for example. I can save that as a nest job, and if I'm happy with that, I just hit OK, and we output the process of the nest job to file. So what actually happens here is DXF files are created for each of the different stock types. Once those DXF files are created, we don't just stop there, we actually generate and load back in those DXF files into NX part files, so you as a user can actually see the result right inside NX without having to load another application. And we can see here we have sheet 1, Testo 1, we have one of them and it's using the metal 10 stock. And we have Testo 1 under bar 1, we have one of those and it's using the metal 10 stock. So there's our nesting finished. If we have a look at the layer settings on here, as I mentioned before, if we just turn everything off, we can see layer 1 is the actual cut layer. Layer 2 is the marking, so here we've got all the textual marks that I've added, and layer 3 is all the additional marking. So if we want to go back and rerun that, or maybe do something slightly different, obviously everything's now gone from the dialog, but I can go back and I can load my nest job as I did before, and all of the information is loaded just as it was. And what I'm going to do here is I'm just going to run that nest job again and show you some of the capability in terms of the preview of each of the different output jobs. So now we have our results here. We can see the preview for number 8 here, and I can actually click on the nested stocks and we can see the preview for each of the different ones. I can go back to the first run, which used 3 sheets, and we can see a preview of that, and that will then load the additional information such that we can see the utilization for each one of those, and we can do that for each one of these outputs. Also output to disk for each nesting job is a nesting report that gives you information such as the material, the stock dimension, the nest length and width, and the utilization, and the total cut length and the number of parts nested. If we scroll down to the top of the next page, we can see the actual part names with a small preview. The quantity of those have been nested and the cut length for each part. So that's NX 2D nesting for this release of NX.